Hi, I'm Mark from Trinity. In today's video, we're going to show you how to make what I call a warped coffee table. We're going to show you how to bend concrete before it's final set. First thing you'll need is a rubber form. This one is made with Polytech 7445. I like the 7445. It's good for tile. It's good for because it's flexible. You can strip it easier. It bends in a tighter radius than the 7560, which is good for larger table. This, I simply took a piece of MDF, medium density fiberboard. I machined the edge to give me a little bit of a slight round on it. Put that down, sealed it, waxed it, poured my rubber on it. We have rubber available in stock. Just call us and we'll advise you on which rubber to get. Stripped it, and then we made a wood form so that when we bend it, it will return to the same place every time. Next thing we wanted to do was, when we bent the table, we want both sides to be equal, and we wanted the bend to be proper on both sides. We found that by laying bendable plywood, this is available from specialty shops, it only bends in one direction. But by laying down bendable plywood and building a form with hinges, we're able to allow the plywood to slide over the form. One of the difficulties we had before we put this bendable plywood on is the rubber would catch when we tried to bend it. This gives it a very uniform bend on each side. We put a little bit of a baby powder on here so that when we put the rubber form on, we have an exact spot for it to go to. We're going to bend it up like this. We install a little catch to hold it. Check it for square. We'll use a bucket to get it perfectly square once we have it bent up. And that's it. You'll see things happen quickly. That way we know when our table is done, we've got both sides. On this side here, these you'll see as we bend it up, the form will tuck up inside here so it doesn't want to flop over. So in the end, we'll have our table bent right like this, and both sides will be equal, the height will be equal, and the bends will be equal. It's really easy to build one of these. It's just some plywood, a couple hinges, some screws. As you can see, you reset your hinges. This works well for items you want to repeat, or you could do a one-off with it. Any way you want to do it. We're going to batch it up and dump it in. Here's the mix design we're going to use to make our warped coffee table. You can warp any mix. You don't need to have a fast setting mix. The advantage of a fast setting mix is you don't have to wait an hour to warp it. Now, if it was greater than 90 degrees in our shop and our batch temps were up in the 80s, you can use 50-50 sand cement mix. This is a basic GFRC mix. If you want a little bit higher strength, out of this cement total, you'll go 90% Portland and then 10% silica fume. If it's less than 60, I would say less than 90. Right now our shop's about 60 degrees. We're going to use 50% sand in our mix design, 50% cement. Our total is going to be 50%. Out of this, we're going to go 40% Portland, 10% CSA, or calcium-sulfur aluminate. All we're doing is adding a percentage of this. This would make up half of the equation of our total mix, where we put 10% of that would be CSA. And you can still split your Portland. You can add 90 Portland, 10 silica fume on this side. Hope that doesn't get too confusing for people. Then it's just admixtures. 3% Trinix GFRC admix. 3% of the cementitious weight. Cementitious weight would be this or this. Total cementitious. And then 0.5 to 1% Trinix plasticizer. This is the part that's going to make it fluid. We want this mix to flow. We're going to do a direct cast, meaning there's no face coat. We're going to dump it in the form, shake it around a little as we trowel it, and you won't see any fiber, even though we're direct casting with no face coat. You can call us up, and we'll walk you through the mix design if you need any help. Here are the actual batch weights we're going to be using. We're going to do 2 batches to do this. We've got to have both weighed up, be real quick about it, make sure they're both the same when we dump them in. Spread the first one on the bottom, next one on top. 30 pounds sand in each batch. We're using a 40 mesh sand. 30 pounds cementitious. Out of that, we're breaking it up as such. 21 pounds Portland, 6 pounds CSA additive, 3 pounds silica fume. The only reason I'm using silica fume in this one, you'll see it's a long span when we're done. I need that extra 2,000 to 3,000 PSI to make this table work. Out of that, we're going with 3% of the cementitious total, or 0.9 pounds Trinity GFRC admixtures. Then we're going with 0.3 pounds, or 1% of the cementitious total of Trinity plasticizer. That'll make it very liquid. We're going to use 1.8 pounds of fiber. The way we arrived at this fiber is we put 3% of the total dry weight of the mix. There's the total dry weight, 30 and 30 is 60. 3% of 60 is 1.8 pounds. We're going to use 3/4 inch 200 filament fiber. Now the reason that's going to work is we're going to have plasticizer. We're going to use 8.4 pounds of water. That'll give us a 0.28 water cement ratio, will give us probably 12,000 PSI using these ingredients. Well, that's about it. We'll just be ready with the water. We want it liquid enough to cause the fiber to float off the face ever so slightly. I think we're ready to batch.
All right, so what I got here is we're doing 2 batches of 60 pounds, so they won't fit in a bucket if I mix it all together at once. So I have my cementitious, my admixes, and my color all in one bucket, and then I have my 30 pounds of sand in another. I've got my 8.4 pounds of water, which is at a 0.28 water to cement ratio, and I also have my fiber all weighed out. What I'm going to do is I'm going to mix the dry cementitious and additives together first, and then I'll add some of the water, about 80%, then I'll dump in my sand, add the fiber, and then add more water if necessary.
I like to spread the first batch out over the whole thing, and I'll dump the next batch right on top of this batch. You can see it should flow very nicely. You want to see air coming up. The air popping up is your concrete self-consolidating. Take your trowel, add a little pressure, work it back and forth. This will displace any, hopefully dislodge any air bubbles, help to. next load on, done. We've got it down. Right now I can see bubbles coming up. That's what you want. You want it to be self-consolidating. 75 degrees, it'll start to run away. It'll get to like 80. That's when you know it's almost ready to bend. You can do a trial bend too. Make sure your form's flat. Watch the temperature and just wait till it's ready. There are a couple of clues as to when it's ready to bend. One is temperature rise. Right now we're at 82. We started about 72, so the CSA is starting to kick. The next is the sheen starts to disappear. There's very little bleed water. And then you do a little test bend. You bend it. Does it want to slump? In this case, yes. It's almost ready, but not quite. And it's cool today, so it really won't run away from us. It's going to be 15, 20 minutes. Right now we're at 82, 83. I think we're about ready. It's feeling kind of warm to the touch and firming underneath. Maybe just another minute or two. But you can see it's getting firm. The sheen is gone. Let me do a trial. Worst case scenario, I'll have to bend it back down. Bend it. I want it to go up. How's it look, Benny?
Looking pretty good to me.
Gonna lock it in. And it looks to me like it's holding. I tend to bend too early rather than too late. Too late and you'll get a crack. Too early you'll slump a little. I just adjust my 90. Just a little bit, huh? Then if you've got any cracking, this one looks pretty good. I'm going to leave it as is. You could always take a trowel, hit it just a little bit. I think I'll look okay. Obviously you don't want to vibrate it. Good. Now let me see if my other end is ready. This end's a little bit cooler. Yeah, I can see I'm 85, 80. A little firm. I'm going to go ahead and bend it. I said you want it to speed up in there. Look okay there? Good? Get up in there?
You're catching. There you go, hold on.
Okay, let me make sure it's got your 90. What we did last night, since our shop is only 60, is we used these, I call them Walmart electric blankets, the kind you put on a bed. You could buy more expensive ones. As long as you're getting your concrete above, I would say 100, you can strip it. 110 is even better. You can strip it the next day after like 16 hours. To do that, you're going to need supplemental heat. And our shop's 60 degrees in the winter. When our shop is 60, concrete doesn't come to a standstill, but if you cover it with plastic, you would probably need 7 days to equal what we did overnight by heating it to above 110. We know it's going above 110. 102. That was 102 this morning. That's warm enough because number one, it has CSA in. Number two, it was covered and heated. So you cover it, heat it, lock the moisture in. It was 102 this morning. We'll be fine. beautiful. This is 80 grit wet dry sandpaper. I would never use 80 grit on the finished face, but for this back side, I just want to make sure I shave off the fiber so you can run your hand across it, make it look uniform, trim my edge, etc. Now we're going to show you how to finish something in a hurry. We're not going to use a mechanical grinder. What we're going to do is open up the surface with a 10-to-1 acid wash. What that will do is it'll eat through the cementitious paste. It'll leave the sand proud, meaning it'll feel like sandpaper when we're done. That way when we go over it with wet dry 400 grit sandpaper, all you're doing is flattening the sand to have a surface. It's a real easy way to get a good finish. You want to remember, it's like acid staining. Where the acid hit first, it will mark the most. So if we were to start here, allow the acid to run down the edge, it'll affect that and it may leave a line you'll see. What we'll do is we'll start at the bottom, work our way to the top. Start at the bottom, work our way to the top. You'll feel it as you're using it. The surface will get grittier. And if you got crazy with a 5-to-1 or something, you hurt it. But here we're going to use a 10-to-1. Start low, work our way high. We used Johnson's paste wax on our mold. So the first thing we're doing is taking the wax layer off. You'll see the color of the cement paste start to come out. That's how you know you're starting to get into it a little bit. Now I'm starting to see some dark lines. So I know I'm starting to get in there and I can feel it actually getting a little bit coarse as I'm doing this. Just keep working it around. You'll feel it, see it. Our concrete's so dense it almost rejects water too. You can see the dark lines starting to come out. It doesn't happen instantly because it's 10-to-1. And you don't have to worry about getting crazy and neutralizing everything instantly. Now you can really see it. Stop rejecting water. All we're looking for is to just break through that cream layer a little bit without a whole bunch of mechanical scrubbing. I'm not really worried about neutralizing this, but I will rinse it before I go on the top. And then just look at it. Looks pretty good to me. I'll hit the other side. Now that I've got my edges done, I'm going to hit my top. I like to start with a moist but not a soaking wet slab. Here again, I'll put the acid on. You can see it's got a little bit of fizz going. This rejection's probably the wax, partially, and the fact that the concrete's very strong. It's extremely dense already. Just keep moving it. Turn it back on, Ray. That's alright, it's got a little glare. My production assistant's screwing up. This is a quick way to do any countertop that you do. Couple clues is you're looking for it to stop rejecting it. That'll let you know all the wax is gone. That's your edges. What happens is as you're applying the acid, the concrete itself is neutralizing the acid. Incidentally, as you recall, we poured this with no face coat. So if we're very careful about using acid diligently, lightly, and lightly sanding, we'll see very few fibers. I'm going to give it a quick rinse to get all my neutralized acid out of the way. Now I can feel the grit of the concrete. It's harder to push the rag along. That's one of my clues that I'm getting there. And I can see a little bit of darkness coming off. That's all you're looking for, and you're done. That's it. Move on to the next step. Okay, that's it for that. Rinse with water. Then we're going to use a 10-to-1 ammonia wash. That'll neutralize our acid. There's our ammonia there. This is a 10-to-1, 10 parts water, 1 part ammonia. This will neutralize the acid. Do not use baking soda to neutralize acid. It does a incomplete job and it leaves residue behind that can affect your sealer. Always use ammonia. It works great. Here again, the concrete is so dense it's actually rejecting anything you put on it. It's probably 8,000 psi by now, based on our mix design, what we did, how we cured it. And I feel pretty good. We've got everything neutralized. Now we're going to go on to the sanding stage. Since I don't want to show any fiber, or very little, I don't care if a couple fibers show, and I just want to get it smooth enough to seal, I'm going to go ahead and use a 600 grit wet dry sandpaper. Now since we acid etched it, all we're doing is leveling out the sand basically. We're cutting in a little bit, but you can see how hard it pulls here versus once you're done it pulls soft. So it's going to be feel and look. And here again, I'm not showing any fiber. Once you get good at it, you can get processing down to a matter of 10 or 15 minutes versus getting all the power tools out and going at it. This is visual as well as feel. I want my piece to have some modeling and movement in it. So I'm not worried if one spot's a little darker, one spot's a little lighter. I want that. We've got it sanded to 600 grit. And as you can see, there really isn't much fiber showing, but we've broken through that cream layer and given it a uniform look. Squeeze it off, wipe it down good, and depending on the sealer you use, we'll be ready to seal either this afternoon or tomorrow. We will show you how to add stiffness to it next. Now the next thing we have to address is the fact that this is only 3/4 inches thick and it's a 5-foot span. With GFRC you can't do a 5-foot span 3/4 inches thick without some type of reinforcement. If you put, it'll probably take about 400 pounds to break it right now. It's a coffee table, so we want to design it so that 3 people could sit on it without too much trouble, or you could set books on it or anything like that. There's a couple ways we could have done it. We could have put a thickened beam, maybe only in the center, to give it rigidity. It's almost like a drop edge on a sink that you don't have to worry. Or we could use some kind of truss system underneath, maybe one in the middle of the leg. What we're going to do is drill holes in the end. We're going to run metal rods from one end to the other. It's going to force this part together, which means for this to fail, the rods would have to get longer, or this would have to collapse and shear. Which, if you watch a video where we test one, that's exactly what it does. So next we're going to put a level on it, make sure the top is flat. If it's not flat, we can actually tune it with our rods a little bit. This concrete right now is about 7,000 or 8,000 psi because it's 16 hours old. In 7 days, it'll probably be over 10. In 28 days, it'll be 12,000 or so, based on our testing. Once it hits 12,000, it's going to want to hold its shape. If we were to leave this go right now, they call it long-term creep. Just from its own weight, it would take a tiny bit of a sag. The rods will counteract that, and we don't want it to pull it together, so for now we're going to install rods, crank them a little bit, and we're going to put a stick on the bottom so that the bottom doesn't want to cave in. Once it gets mature, meaning probably 3 or 4 more days, we can take that stick out. It won't want to go anywhere. That's what we're going to do next. We'll measure up, we'll put the rods just below the bend, and true it up, and then leave it till we're ready to seal. Since this is GFRC, it's very easy to drill, which seems odd. It's easy to drill, it's easy to cut with a tile saw, believe it or not. You want to drill through with a masonry bit. Now next, with the bigger hole, I'll drill some from this side, flip around, come to this side so I don't have a blowout. There's 2 things we want to do. We want to get this flat. Right now there's about 1/8 of an inch gap underneath my straight edge. But while we're getting that flat, we also want to maintain squareness of our edges. This edge could be pulled in a little bit. So and we don't want to pull the bottom in. So what I did is I cut a piece of wood that fits the dimension that it should be in the bottom. And then we're going to treat all 4 corners individually. We're going to get squareness while torquing our nuts. I left them a little bit long. It doesn't take much at all. That's it. 2 turns. Maybe 1 more. And now it's twisting and flexing it. Keep an eye on the squares. See, that could come in a little more. Could be squeezed a little more. That sounds almost good. Be careful you don't crank too much. See, my board is tight at the bottom. That's perfect. That's good. That could actually come just a touch more. Before I do that, I'm going to get my other side. That's almost good right where it's at. Touch. Flat, flat. Now, look for 90s. I've got a 90. I've got a 90. That's good. As I said, this is about 8,000 psi down. My bottom board bowed up a little bit. I'll probably just throw a weight on it, to tell you the truth. But the concrete's still young. It's still young and it's got to be moving. That'll be fine. So once it hits probably 10 to 11,000 PSI, it'll almost lock into that shape, and that's it. As you can see, give me a close-up right here, Vinny. Now, we didn't use any face coat. This was direct cast, and there's no fiber showing, which is pretty cool. And it's got a nice uniform finish. This will look good when it's sealed. That's it for our work coffee table. Like I said, I've got to wait for this concrete to mature a little bit. In the summertime, it would do so quickly. Today in our shop at 60, I would say I wouldn't feel good. I'd feel good about shipping this in 7 days. I wouldn't ship it just yet. The sealer choices for outdoor, I would choose Stamp Shield. It's color enhancing, and the maintenance is no problem. 5 years from now, you got to reseal, it's no problem. I would use stainless rods for outdoor. You could put a shelf on here if you wanted for indoor. We may or may not do that. This, we want a more of a matte finish, and it's going to be indoor, so we're going to use H12. We've got videos on how to apply that. If you have any questions, call us, and we'd be glad to help you with anything.